Hey guys, Dr. Brown here with Kubo Math, and tonight we have an integration problem, the integral of e to the x sine inverse e to the x dx. Whoa, what to do? All right, let's get after it. Okay, you know the tools. If you follow the channel, we have U sub, trig sub, integration by parts, partial fractions, power reduction, long division, completing the square, and what we call methods of quadratics. Okay, I would encourage you, if you want to be successful in your Calculus 2, if you can master these, what was that, 1, 2, 3, 4, 5, 6, 7, 8, those 8 integration methodologies, hey, you're well on your way to kicking some major butt there in your Calculus 2. Okay, we have 2 pieces to this one. I know I can integrate e to the x. I know I can differentiate sine inverse e to the x. Hey, so I'm going to use integration by parts. And I'm using the DI method. It's the same as the old method. It's just a tabular form that allows us to keep up with the pluses and minuses. So don't freak out, okay? So sine inverse e to the x, I'm going to differentiate that, and I'm integrating e to the x, that's a terrible x, e to the x dx. Okay, so the integral of e to the x dx, the integral of e to the u du is e to the u, okay? So the integral is e to the x. Now, sine inverse e to the x. If I had a triangle, and this is theta, let's say it's 30 degrees. So that's a right angle. This is 1 square root 3, 2. Okay, so sine inverse of 1/2 equals what? Equals theta. It equals 30 degrees. So when you see this, all it's saying is that's theta. If that's theta, I need to come up with an equation for d theta. Hey. So let's think about that. Well, this implies that sine theta equals e to the x over 1. Hey, I can take the derivative of this, outside function, inside function, using a chain rule, and I can end up with a d theta. So the derivative of sine theta is cosine theta d theta. And that equals the derivative of e to the x is e to the x. Okay, so d theta equals e to the x over cosine theta. So I divided both sides by cosine. 1 over cosine is what? Secant theta. Okay, let's get us a triangle back up here. All right. We said sine inverse of e to the x implies that sine theta equals e to the x. So sine is opposite, this is theta, opposite over hypotenuse. So that gives me this side is 1 squared, which is 1, minus that side squared. Now we have another rule here. A to the m times a to the n equals a to the m plus n. So e to the x times e to the x, that's e to the x squared, equals e to the x plus x, which is e to the 2x. So this becomes e to the 2x. Now secant theta, cosine is the adjacent over hypotenuse. Secant is the opposite of that. It's the hypotenuse over this. So what do I have? So d theta is e to the x over secant theta, which is 1 over square root 1 minus e to the 2x. So derivative of sine e, inverse sine e to the x is the same as the derivative of theta, which is d theta, so that's e to the x over square root 1 minus e to the 2x. Not yet, okay? All right. Okay. You know, in the DI method, we take the product of the diagonal, and then we integrate, we stop when we can integrate a row. By the way, I would encourage you to go to Black Pen, Red Pen, to his YouTube channel and look at the DI method. The guy's phenomenal, and he does an excellent job. Actually, that's where I learned this, because I used the old school method, and when I first saw the DI, I thought, oh no, it's a gimmick. And then I worked a few with it. Oh, why didn't we learn this years ago? I have no idea. But anyway, there it is. All right, so what do we have? We have this equals the e to the x. So this is positive, 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 times sine inverse e to the x minus the integral of e to the x over square root 1 minus e to the 2x times e to the x dx. So this is the integral of e to the x times e to the x is e to the 2x over square root 1 minus e to the 2x dx. Okay. Let's let u, see now we've used integration by parts. Now we're going to the u world, okay, and we're using another tool. So we're going to let u equal 1 minus e to the 2x. du then, derivative of constant 0, and derivative of e to the u is e to the u du, not this u, but so this gives me minus 2e to the 2x dx. So du over minus 2e to the 2x equals dx. Hey, you can already see this guy is going to cancel this one. All right, now we have minus, that's this negative, e to the 2x over u to the 1/2. It's a square root sign there, u to the 1/2, du over negative 1/2. So that makes this a positive. I'm going to put that 1/2 right there. Du over this negative 1/2, so it made this a positive, e to the 2x. So that cancels this one and that one. So we have plus 1/2 the integral. I'm going to bring this u to the 1/2, bring that up. That's u to the minus 1/2 du. All right, let's see. Don't forget this guy. We'll just draw an arrow. I'll bring him down later. So if I increase this by 1, so that's plus 2 over 2. So negative 1/2 plus 2 over 2 gives me a positive 1/2. Divide by 1/2 means I'm multiplying by 2. So these cancel. So I end up with u to the 1/2. Now what was u? 1 minus e to the 2x. So that's 1 minus e to the 2x to the 1/2. That's a square root sign there. Plus that, okay? Let's bring this one down. E to the x sine inverse e to the x plus square root of 1 minus e to the 2x plus c. And that, my friend, is the integral of e to the x sine inverse e to the x dx. Okay? Now you may be thinking, well, wait a minute. How do we know that's correct? If you want, let's take the derivative and just see if it's correct, okay? Screenshot, 3, 2, 1. All right, let's wipe this all out. Oh, I don't want to, I want to remember that one because I'm going to need to take the derivative here in a minute. Okay, we have e to the x sine inverse e to the x plus 1 minus e to the 2x. It's the square root. And we're going to take the derivative of that with respect to x. Okay. Oh, I erased it anyway, didn't I? Let's not forget that. The derivative of sine inverse e to the x was what? It was e to the x over square root of 1 minus e to the 2x. That was the derivative. Let's not forget that. Okay. You know when we're taking the derivative of this, and there's two x terms here. So when you look at the derivative of product, we have, let's say I have product ux. That's the first one times the derivative of the second one plus the second one times the derivative of the first one. Okay, that's what I have here. I have the first one, which is e to the x, times the derivative of the second one. That's why I didn't need to lose that. E to the x over square root 1 minus e to the 2x plus the second one, sine inverse e to the x, times the derivative of the first one, which is derivative of e to the x is e to the x dx. So I'm going to put it here. Okay, so that takes care of my first term. Plus derivative of this one. Now I have a chain rule opportunity. Let's bring this guy down. So it's 1/2 times what's on the inside. And then I decrease this by 1. So 1/2 minus 2 over 2 gives me minus 1 over 2. Well, now I've got to get rid of that. Okay, times the derivative of what's on the inside. So that's minus 2e to the 2x. So we bring down the 2. The derivative of 2x is 2. 2 times this negative 1 here is a negative 2e to the 2x. Okay, so what do I have? E to the x times e to the x is e to the 2x over square root 1 minus e to the 2x plus e to the x sine inverse e to the x. What do we got here? A negative 2 times 1/2 gives me a minus 1. Okay, minus 1 times e to the 2x. And then this is to the minus 1/2. So I'm going to take it to the denominator, square root, that's my to the 1/2 power, 1 minus e to the 2x. And of course the derivative of a constant is 0. So you'll notice you have e to the 2x over the square root of 1 minus e to the 2x minus all that same stuff. So this and this cancel, and it leaves me what? Hey, e to the x sine inverse e to the x. So we've just confirmed that our answer was correct. So this integral is e to the x sine inverse e to the x plus 1 minus e to the 2x plus c. Okay. So anytime, actually, when you work the odd problems and the answers are in the back, this is number 82. We've jumped over to the even problems. The answers are not in there, so with each one we're having to work the derivative to make certain we've gotten it correct. Okay, why are we doing this? Together we're trying to build a better tomorrow, and do that how? Do that through math. Keep studying, guys, and we'll talk to you next time. Thanks.